Good day everyone, my name is Rib Flores and welcome back to my YouTube channel. For today's video, we will discuss about the integrals of trigonometric functions. And the objectives of this video is that the learners are now able to solve for the integrals of the trigonometric functions. But first, let us define these terms. First is we have the integral calculus. Integral calculus defines as it helps in finding the antiderivative of a function. Next is what is integrals? Integrals is the antiderivatives of a function. Next is the integration. Integration defines as the process of finding the antiderivative of a function. So if we connect these three terms, if we do integrations to solve for the integrals, we must first learn about integral calculus. So, to connect to our topics for today, the integral for the trigonometric functions, it is just we need to find the antiderivatives of a functions involving the 6 trigonometric identities, namely sine, cosine, tangent, cotangent, cosecant, and secant. So this is the properties for the integrals of trigonometric functions. First is we have this in the integral of sine x dx, which is equal to negative cos x plus c. Next is we have this integral of cosine x dx, which is equal to sine x plus c. Next is we have this integral of tangent x dx, which is equal to ln, absolute value of secant x plus c. Next is the integral of secant squared u du is equal to tangent u plus c. Next is the integral of cosecant squared u du, which is equal to negative cotangent u plus c. Next is we have this integral of secant u tangent u du, which is equal to secant u plus c. Next is we have this the integral of cosecant u cotangent u du is equal to negative cosecant u plus c. In solving integrals involving trigonometric functions or trigonometric identities, we should apply it, or we could learn more about it if we apply the properties and the terms we have defined in examples. So first example is to find the antiderivative or integral of sine quantity of 4x minus 2 dx. So in this case, we let u as 4x minus 2 and we let du as 4dx. 4dx, since the derivative of 4x minus 2 as 4dx. So, and if we solve for du or dx rather, we came up with dx minus 1/4 du or du over 4. And by that, we are able to solve the integral for these trigonometric functions. We exclude 1/4 as the value of our dx. We have 1/4 du, we just exclude 1/4, and then sine u, which is our u is 4x minus 2. So we came up with 4 is equal to 1/4 multiplied to negative cos u, since it is the antiderivative of sine u du. Next is just substitute the value of our u to our new given. So we came up with negative 1/4 cosine 4x minus u plus c instead of putting u. So that will be the final integral of this trigonometric functions as our example number 1. Next is we have this example number 2, which is the given as tangent squared x dx. First is just we find find the value of tangent squared x. So we came up with is equal to the integral of quantity of secant squared x minus 1 dx. And then apply the distribution of signs. So we came up with the integral of secant squared x dx minus the integral of the x is equal to tangent x minus x plus c, since the value of secant squared x dx is tangent x and the value of the derivative of dx is x. So we came up with tangent x minus x plus c. Next example is, how about the integral of cosine squared or cosine 2x all over sine cubed 2x dx. So we let u as our sine 2x, and then our du is equal to 2 cosine 2x dx, and then our dx is 1 half du cosine 2x dx. And then we substitute it to came up with this form, the integral of 1 half dx all over u cubed minus, we exclude the 1 half, so we came up with 1 half all over 1 half the integral of u negative 3 raised to the power of negative 3 du. And by that we are able to solve it. So we came up with 1 half quantity of negative 1 half u raised to the power of negative 2 plus c. And then next is we solve for we combine terms by distributing the 1 half outside the quantity. So we came up with negative 1/4. We substitute our u back, so we came up with negative 1/4. The value of u, so we came up with negative 1/4 quantity of sine 2x raised to negative 2 plus c. So to solve it, so we came up with negative 1/4 quantity of 1 minus 1 all over sine squared 2x, since negative 2 is if we finding reciprocal values, so came up with 1 all over sine squared 2x plus c. And then we combine terms, so we came up with negative 1 all over 4 sine squared 2x plus c as the integral of this third trigonometric functions as our example. Next is, how about the integral of cotangent for cotangent raised to the power of 4x dx. So first is we have to rewrite the given. So we came up with the integral of cotangent squared x cotangent squared x dx. And then we find the value of cotangent, the other cotangent squared x. The other ones we came up with the integral of cotangent squared x quantity of cosecant squared x minus 1 dx. And then we came up with the integral of cotangent squared. We distribute the cotangent squared to our inner to the quantity. So we came up cotangent squared x cosecant squared x minus cotangent squared x dx. And then we solve for the integral of cotangent squared x cosecant squared x dx minus the integral of cotangent squared x dx. And then we solve for this one. We find the value again of our cotangent squared x dx. So we came up with the integral of cotangent squared x cosecant squared x dx minus the integral of the quantity cosecant squared x minus 1 dx. And then redistribute the integral sign to our second equation. So we came up with, but first we already find the value of the first equation. So we came up with the negative cotangent cube x minus 3 minus the quantity of the integral cosecant squared x dx minus the integral of 1 dx. And then we came up with negative 1/3 cotangent cube x minus quantity of negative cotangent x minus x plus c. Cotangent x is the integral of the cosecant x squared. So we came up with this as our final answer, which is the negative 1/3 cotangent cube x plus cotangent x plus c as the integral of the fourth trigonometric functions as our given example. And that would be all for today's video. I hope you learn, and please do subscribe and click the notification bell for you to be updated. Again, I would like to give credit for this LM or learning material that serves as my basis in doing or creating this video to Sir Matthew Caneda as our instructor.